Remember the last electronic product that you didn't want to use anymore? What did you do with it? There are a lot of different disposal options. You could store it, donate it to Goodwill, go to a municipal collection point, trade it in for a new product, just to name a few. A variety of factors influence the decision and action of consumers to bring electronics to collection points to be processed in a circular economy. Habits, the physical condition of the product, its size, privacy concerns about personal data, awareness of collection points, the offered compensation, and more have an effect on consumers. Considering the multitude of interconnected and dynamic factors, designers and engineers could greatly benefit from more research and development on the subject from a consumer perspective. Securing a predictable flow of used electronics improves control over the quality, volume, and timing that are necessary for circular processing. However, collection solutions are often considered as a part of reverse logistics and are looked at through an operational lens. Also, the last phase of consumption receives a lot less attention than the purchase and use phases. Fortunately, interest in this field is growing in design, and support from designers and engineers is emerging. Let's begin with the structure of the final phase of consumption. It combines two parallel processes. The first is physical separation from the product, where the consumer physically prepares the product by, for example, cleaning it, and at the end acts up on the disposal decision by, for example, selling it. The second is the mental and emotional separation from the product, during which its value for the consumer is eroding over time. The phase thus combines both visible and invisible processes. Now, what happens in the head of consumers during these processes? The phase could be split in 6 stages, starting from the moment one is thinking of separating from the product, searching for options, evaluating these options, preparing for the separation, doing the final act of physical separation, and finally, the outcomes of this final act of physical separation. During my PhD, I analyzed various design projects where designers created valuable collection experiences for consumers to find patterns to give direction to design of endings. Special care was put on the design of interventions in the hardware, software, product packaging, the collection service and its infrastructure, and the development of routines and rituals surrounding collection. Based on these design projects, I found 10 design principles for the collection of mobile phones. For instance, hold users by the hand to say goodbye. The process of collection is filled with uncertainties and tensions for consumers. They should be guided through this unknown collection experience in a confident, effortless, and seamless manner. Or you could think outside of this last phase of consumption. As mobile phones are most often purchased as a replacement for an older phone, connect this purchase of a new phone with the collection of the used phone. We can see this is being integrated more and more in online retail environments in the recent years. Another design principle specific to mobile phones is to consider the body and the soul of devices. As we're using our phones daily and share our life with it, the separation from a used phone can cause stress due to, for instance, attachment to the product or data loss concerns. To soften this transition, a share of this value can be kept through the transfer of the phone's digital content, or soul, by reincarnating it from the used phone's body to the body of the new phone. These proposed design principles specifically focused on a valuable collection experience for mobile phones. More methods and tools on designing for the last phase of the consumption cycle are to be expected in the near future. The consumer journey can be studied in detail, and consumers can be more involved in the development of future collection solutions. This will improve volume, timing, and quality of collected flows of electronics, and in turn, improve recycling.